Hi, I'm Andrew Armstrong, welcome to the back of his Teardown Lab. Now, this kit is not so much of a mystery because it came with something. It came with a lamp holder, and I've actually fitted a lamp, and I fitted some connecting wires because those will come in very useful later. And I could see in the packet that it contains a microphone. So I could only deduce the one obvious thing, that this must be a sound-activated light. And how cool is that? Let's whip out the instructions again, totally in Chinese. That's not going to help us. However, we have a circuit diagram, and that may well help us indeedy. Yes, indeedy. Let's see what we've got here. We've got power coming in. We have some rectification going on. So there's our microphone and the transistor. So it's all, you know, doing some magic stuff. 1 meg here. So you've got 1 meg coming into the base. Mains power. So the mains power is coming in. It's going to be rectified onto this rail. This is crazy, guys. Just make sure when you make this, you just don't want to touch anything, because it's all going to be mains voltage. You know, even though the voltage will be dropped through some of this stuff going on. It's 150k. You know. Be careful. That's all I can say. Be very careful. So here's the circuit there. PCB rather. There's our couple of little transistory things. In fact, two. So one is this thing. And is that something else? An MCR1. What is that? That's it. The MCR. Is that some sort of thyristor? I don't know. If you're playing along at home, guys, and I know some of you are actually electronics people, you can tell me what exactly an MCR 100 is without me having to go and have a look at data sheet in the middle of the video. Let's just crack on. We won't worry about it. We don't worry ourselves with these details of these kits because we assume for the £1 or whatever it is we spent on the kit that those guys assembling it in China and designing it just knew what they were doing and made it properly. Sounds fair enough to me. Look at this. This is an interesting one, by the way. R6. This looks like suspiciously a light dependent resistor. So could this circuit come on only in the dark, and if it hears a sound? This could be quite useful, really, a bit of fun. Microphone footprint slightly wrong for the packaging. That's a shame, because it means it'll either hang off the edge of the board or sit inboard a bit too far. What should we do, guys? Let's have it sit inboard because we don't want it to get knocked. Let's start soldering, shall we? Happy days. Get all these tools out of the way. God, I should really tidy up my desk. So those of you who are doing electronics at home, do you is your desks lovely and tidy? Or does it slowly build up, fills up with detritus and component leads, all sorts, until there's a point where you just really have to hose the whole thing down and start again? Found a piece of paper, by the way. Can any of you translate that for me? It's probably saying, danger, this kit is not to be constructed. It's just for educational use only. Only. I actually have as well a really nice enclosure that might suit this. So if it does work out, maybe I'll set it in my garage or something as a nighttime alarm, or perhaps just a nice little automatic light for people to use. So that's the light dependent resistor, the LDR. Just have a few resistors. I'm going to leave the resistors to the end. Again, you know they're not my favourite thing. I'm just going to pick out the diodes, pick them out. So those diodes are going to be providing the rectification of the circuit. One goes in there. Now if you haven't, go across to bigclive.com's channel. So type in right now into, well, not right now, wait for my video first, but later, bigclive.com, and if he was doing this video, because he is an actual genuine engineer of electricas, he'll be able to tell you what's going on here. He'll know all the analog electronics behind this, and give you even probably a rundown of the science behind it too. I, on the other hand, only know about noughts and ones, so I can't help you in whatever crap accent that was supposed to be. I canna. I think that's Scottish. Possibly. Yes, Miss Moneypenny. Ow. Oh, James. Yes, Miss Moneypenny. Yeah. I'm not good at accents. I'm not even sure I'm good at my own. Those of you into accents, what is my accent? Where am I from? I think we've asked this in the past, and I'm going to ask it again because so many people do not know. If you've met me in person, do I sound different in person than on my videos? Perhaps being in front of a camera changes you. Putting in the big electrolytic now. It's a big one. So I'm quite worried about this. There's a definite possibility that it might explode in my face, because you know, you've seen before previous videos of things exploding in my face, and it tends to be a feature of mains videos, because when it goes wrong very wrong and very quickly. And if you've misread one of these components, like I'm likely to have done, you're going to experience that probably quite soon. So let's have a look now. We're going to have these resistors, and every resistor is different, which is always pleasant. A 1K, 150, 1 meg, 10K, and a 3.9. So, sheesh. You know, when I've used this before in the past, sometimes it hasn't correctly read because I think the battery's dying, and I ought to change the battery, but I haven't. So this resistor 1 is... it's saying half a meg. So do we have anything near a half a meg? Not really. So let's put that aside for now. I can't see a sort of 500k on the board, which is worrying. We'll just work our way through. The next one, that's a clean 10k. Brilliant. Let's just pop that 10k right in. Get it on, get it in. Come on. Popping it straight through. There we go. There's our 10k ready to rock. Next is 1k. Brilliant. We definitely have a 1k. I might set up a nice little rig here with clips or something and a permanent ohmmeter just to sort of read resistors, because I'm doing it so often. It's a little bit fiddly. Excuse the noise in the background, by the way, if you can hear it. It's kids screaming. That's quite common in my household. So that's a kind of 115. I do have a 150k hole on the board. Let's keep that aside for now. And this one is 3.8. And actually, yeah, we do have a 3.8, so we can plop that one right in here. It's actually 3.9, but close enough. I don't know what's more likely to be out, my meter or the component. So that's 117k. I'm assuming this one is probably the one, should be in the 150 hole. It's just a bit inaccurate. So that leaves us the last one, which was weird, which is supposed to be 1 mega ohm. It's just reading 0.3. But you know, it's a mains project. What could happen if it went wrong, we don't know. blow up in my face. Let's just roll with it, shall we? That might be a 1 meg. That might be a substitution, but we'll never know because we can't read the Chinese. Oh, here again, a lot of shouting outside. Naughty children being naughty. Maybe if their father wasn't spending all of his time putting kits together in the garage, they would be slightly less naughty. But I doubt it, because kids are designed to be naughty. Did you do anything naughty as a child? I suspect if you're watching this video, you may well have like dismantling things as a child. Perhaps your parents' hi-fi. That's all the resistors done in one hit. Just got one thing left, and that's our LED. And then we just power it up. And I've only got main stuff to power it up with, so that's going to be very exciting. Let's chop all those legs off. One LED. Which is the positive, guys? Is it short leg positive or long leg positive? I have forgotten again. Every single video I have to do this. Perhaps I'm going to etch it now onto this board and we'll know. How useful would that be? How come I've never actually ever thought that before? LED pin out. I've got my phone, I'm just tapping it in the corner. There we go, look, it's right there. Long leg positive. And that, you know, I should know that because it's not even just for the LEDs, it's for the electrolytics as well. It's for everything. It's for everything, man. Right. We're in business, guys. So I've got some bits of wire that we're going to use for the mains, and we've got our actual lamp. How do we hook those up? So this is the J1. I think this is the in. Yes, J1. So these are the mains in, these two pins. So we can do that. In fact, I've already tinned these and they're not actually fitting through the holes nicely. Oh, that one is. Fair enough. Fair enough, Gav. So what's the worst that can happen? Take out everything and blow up. No, the worst that can happen is it'll probably just pop a fuse or blow a component on this board. So prefer it if neither of those things happened, but even if it does, it shouldn't be so catastrophic. Just got to make sure you're not, you know, in any position to electrocute yourself when something does go wrong. So don't panic and keep calm. Think of what's the worst that can happen, really. Though it'll could put in any of this sort of thing. As long as you're not anywhere near it with your fingers, you might pop a fuse on your house, or the thing might bubble and splutter on your desk. You know, if it's something really wrong, which frankly you don't have the components here that'll do that. So there's no really need for you to rush in with your fingers, your naked fingers, and electrocute yourself. So just try to avoid that. I'm going to assume this board is actually non-conductive, and we're going to just put the PCB down like that. How wrong I was. No, it's okay. I'm going to turn off my soldering iron. We don't need that anymore, and I've got a rather jury-rigged way of hooking up the power. I know I should be putting a plug on this, but I'm not going to. I've got here a computer kettle lead, and I'm going to do the, of course, really fun thing of just poking these wires in there. And really don't do that at home because it's naughty. It's dead naughty, and I'll tell you why. Because if you've just got one wire in like that, yeah, and you think, okay, it's still not quite connected, but this was actually plugged into the main, and you touch that, bang, and your finger's gone. So really, don't do it this way. It's friggin' dangerous. I'm doing it because I'm an idiot. So there we go. That's hooked up now. Now look, let's just see what we're going to try to achieve before we do anything. I've got this card, and we know this card is non-conductive, so I might be covering this at one point to cover out this light. Because sound will still go through it, when I make a noise it will make the lamp come on and off even if that's covered. So we might need to resort to that. But yeah, I'm going to plug this in now. So hold on to your pants, guys. Oh, Of course, if you're doing it with a big silly lead like this, which you're not because I told you not to, make sure it won't fall off the table and bring the whole lot down. Ready? Here we go. 3, 2, 1. The LED's on. That's a good sign. Hello! No. Hello! I don't know what kind of noise it reacts to. Maybe not clapping, although the clapping's quite scary because it does sound like electricity. I'm going to turn off all of the lights and some at the bench. Here we go. Hello! Yeah, okay. Kinda. Hello! Now, I would assume that this should be staying on, but maybe it's like a disco light. Disco, disco. Disco time! It's Andrew Armstrong's back office time! Yeah! Okay, guys, so I think that I'm going to unplug this now. I think there's something wrong here because I would suspect it should stay on, but I don't have the means or the knowledge to read the instructions. So yeah, please feel free, if you understand this circuit, to comment down below and actually let me know what's going wrong with this, because it might be quite fun. I do like the actual whole it coming on when there's sound. I think I can turn this into a disco light, but yeah, if you can let me know how to make it permanently come on, I'd really appreciate that. Please like my video, click subscribe, and again, leave comments down below. As ever, thank you for watching, guys. I loves you. Bye.